Okay, here we go with our Winter 21 paper 6.3 this time, and we're looking at question 7. Okay, I've got my answers here on the left and the mark scheme kind of hiding somewhere here on the right. All right, let's get started. We've got a question which we're looking at measuring the energy stored in a spring. Now, that's not something that you will have studied at GCSE level. However, you will have studied springs, okay, and you should be able to understand ideas about extension, etc. Okay, the first thing that you're going to be asked to do is measure. Okay, usual story. Okay, you're going to ask to measure this L0. Let's just check that down there. There you go. Unstretched length of the spring in centimeters to the nearest 0.1 centimeters. So notice in the question it does specify in centimeters, not millimeters. Okay, when I measured it, it was 5.3 centimeters. Okay, you need to make sure that you've got to the nearest 0.1. And so if this was 5 centimeters, make sure we're writing down 5.0 as opposed to simply 5. Okay, the point is that you are using a ruler which has got accuracy, precision, to the to 1 decimal place in terms of centimeters, and so therefore you should be able to tell me 5.0. Now in this case, for me, it was 5.3. I've said this a few times before, it depends on your printer. Okay, so you might find, depending on how you printed it out, you've got a different value. That's okay. All right, just make sure that when you're doing the exam, you read your scale correctly and remember that decimal place. All right, we're then asked to do a little bit of calculating. First things first, we're asked to calculate our values of the extension, where extension is L take away L0. We've got L in the table, and we need to find E equals L minus L0, and that's our L0 value at the top. 2 nice marks here for just simply doing some calculations. Okay, you can see mine are 4.3, 8.7 in the mark scheme. We've got 4.1, 8.5. That's simply because my L0 value is different. So I would get the marks here. Okay, we're then asked to calculate. Now again, this is an equation which, if you were to go and study A-level or IB level physics, you would understand where this comes from. But all you need to do is use the equations. Okay, we've got E is equal to 0.005 times L, which is the load, times E, which is the extension, and we need to put these in, and specifically to 2 significant figures. Now, I don't think I read that correctly when I did this question, but I think I will get the marks. Again, you're going to get, if you use the values in the as according to the intended mark scheme, you would find you've got a 0.0205 and 0.085 here. Okay, now obviously my numbers are slightly different. Okay, there's a mark here for getting the right values. Now, if you notice here, this is in bold. That means you must have both answers correct. You then have to make sure you round, because the question does say to 2 significant figures. So you need to express your answers in 2 significant figures. Now, when I did this, I wrote it to 3 significant figures, but in brackets I've written to 2 significant figures, and in the bottom one I've actually done it to the correct amount, and so therefore we'd get the marks here. Okay, as long as somewhere you've written to 2 significant figures, then you're going to get the mark there. So far, I think a fairly nice question, right? Just a few bits of measuring, a bit of calculating. Pretty gentle for a physics question here. We're then asked to do this statement and reasoning, and this is where I think students again have trouble. This teacher states that when the load L doubles, the elastic energy should increase 4 times, and this is something that should happen. We have an equation for this. Let's have a look there. How do we do this? Okay, we're wanting to use our values for E to state if the values support that statement. In other words, if I have E2, okay, is E2 4 times E1? In other words, is this bottom entry 4 times the value in the top one? Well, the way we would do this is as follows. We would take E1 and we multiply it by 4. You can see there that if I multiply that number by 4, I get 0.086. And if I then compare it to the value in the bottom of the table, that's very, very close. Now in science, we have to be a little bit careful with what close means. In close, we want to think about percentage difference. So what we're going to do there is we're going to calculate the percentage difference. We're going to find 0.087 minus 0.086, dividing by that original number. Obviously a very small number there. We've got 0.001 divided by 0.087, which gives me 1.5%. Okay, and so therefore this is within 10%. Okay, our experimental accuracy, generally we want 10%, and so therefore our statement is yes. Now it's kind of interesting with the way that they line these things up here. In the answer, you're asked to give your statement and then your reason. Well, you might want to start with the reason bit, and that could be a little bit of space to do a bit of calculations, okay? If you look here, okay, and I don't like this about CIE's answering, they've kind of allowed you a bit of a waffly answer here, okay? Firstly, we're expecting a yes, okay? And they would have allowed, the answers are very close. Now, I don't like this because how close is close enough? Some people have different interpretations of what close means. What I really would encourage you to do here is to calculate the percentage uncertainty, because that is, or the percentage difference, sorry, because that is what will tell you whether they're close or not. And I think that if you really want to make sure you've got that mark, percentage difference is the way to go. Okay. All right. Not a lot to go for here. Okay, next question D, simply asking to suggest how the student can extend the investigation. Well, nice use of extend here. Okay, especially when you're dealing with a spring. Okay, I'll let you all laugh about that later. Okay, they can try the experiment again. Okay, repeat with different L values. And I've said here to plot a graph. Okay, we're always interested in plotting graphs. Okay, and we might want to identify the relationships between the energy and the load, for example. Okay, key idea here is that in this experiment, they've only done 2 investigations, right? They've done 1 value, 2 values. Well, standard number for CIE anyway would be about 6 values of L. Okay, so certainly not enough data here. We want to have confidence. We want to have more reliable data. Key correction to the method would be do it again and again and again. Okay, repeat it. All right, last one. Okay, stretch springs are potentially dangerous. Okay, now you notice here I've been a bit of an idiot. I'm calling myself an idiot here. Okay, I wrote the thing in the wrong way around. I don't know why I did this. I think I had a brain fart. Okay, one thing you could do here, one very good safety precaution is always to wear safety goggles. Now you might be wondering why. Okay, well the idea here is that the spring may snap, it may sort of bounce back. Okay, and the worry here is that may make contact with your eyes. Okay, so a very over-the-top safety precaution here would be to wear goggles during the experiment. Why? Well, because they might snap and flick into the eye. Okay, there's a couple of extra examples down at the bottom here. Wear goggles and protect if the spring flicks. Okay, ensure that the spring is tightly clamped. Okay, and ensure that the load is firmly attached. And these are all kind of things to help protect us against some kind of damage which might be caused by that spring or that mass kind of flying around. Okay, I mean, I think this is a little bit over the top, but we do have to think about these things when we're doing science. Okay, how we protect ourselves during the experiment, and that's what we are looking for. Okay. So all in all, I'd say I've gone through this one quickly because I think this is a pretty nice question, a few calculations, a bit of reading here. I certainly think of those 8 marks, we could be on for 6, 7, 8 of those. Okay, as usual, check your answers compared to mine. Check your answers compared to the marks given here. We're looking at question 7. Okay, feel free to pause at any point so you can have a little look. And if you've got any questions, please do let me know. Thank you for watching.